So the presentation will is content of these all these points. We'll start with some background information, then the benefits of induction furnaces, the challenges, what solution we could offer to meet the challenges, the benefits, instructions to use, benefits in terms of like monetary benefit, economic value, and overall trial related and similar grades of the product. So to start with the background, we all know, as far as iron foundries are concerned, induction furnaces and cupola are the two majority routes are followed for melting. Just uh, this is schematic of induction furnace and cupola. However, when it comes to a choice, then it is induction furnace. Is slide visible?
Sir, it's visible for us.
Visible for us. Okay. Okay. So now, though there are two common routes, but most popular is induction furnace route, and the reason is very clear, like ease of operation and productivity. However, some these we can elaborate the benefits in more detail, like use of induction furnace is is giving us ability to produce iron with control chemical composition. Then the tapping temperatures can be precisely maintained. Then we can use wide range of charge materials, like typical in induction furnace, pig iron returns, foundry returns, CRC scrap or MS scrap, borings. These are the common charge mix, and it gives liberty, freedom to use this variety of charge mix. Then environmental pollution is much reduced. Then the stirring effect in induction furnace will will help to quick addition of alloys. So like to adjust the chemistry on like on 11th hour adjustment can be possible. Just uh, add all alloy elements and just transfer the metal. So these are some benefits. However, up, though benefits are very good, but there are some challenges that every foundryman uh, came across while working with the induction furnaces. For example, like the increased use of unshot blasted returns and variable quality scrap, means use of variable quality scrap is on one side it is benefit, but like use of borings, excessive borings, and unshot short blasted returns that could lead to increase in slag levels, and that is one of the major challenge. So you can see unshot blasted returns having a lot of sand, uh, which is used in during charging, will would lead to a slag generation. So slag generation, the heavy slag will get will be there, and also as we know during melting the elements like silicon, manganese, iron, for HRN in HRN case magnesium, they will form oxides and non-metallic compounds. It is a natural phenomenon that we in one cannot avoid it. So during melting, these non-metallic inclusions compounds are prone to form, and as you can see, the more would say dirty or unshot blasted or variety of charge mix would lead to more slag deposition. So that these non-metallic inclusions, they are lighter than the iron and they tend to float or suspend on the metal. And when number of these particles, non-metallic increases, they coalesce and form slag. And this slag have a tendency to attract towards the cooler surface of the refractory, and there it starts building up. As over a period of time, it starts building up. and the more the buildup, that means the furnace lining, actual lining will get increased, and that increase is because of the slag buildup, which actually reduces the flux linkage, or the then furnace will draw more power for the melting. And also the very high chances for that, no, whatever the deposition is there, that will go into the casting through metal transfer. If it is not removed properly, this slagging is not done properly, then there are highly chances the casting will also get contaminated. So also with the buildup, when buildup is heavy, slag buildup is heavy, what apart from this power consumption, which is definitely going to increase because of poor flux linkage, these are the actually challenges. Then bridging effect will also be there. What is that bridging effect? That because of deposition, whatever solid charge we are charging, that will get entrapped in the deposition. It will not enter properly, and uh, you can say, uh, middle there is a solid charge, and at the bottom already there is a molten metal, and continuously because of that power, this upper solid charge which is getting stuck is not will not be able to into contact with metal, and thus there is continuous erosion in the molten metal area, and this also increases our melting, to get the metal ready, that time means it will reduce in melting rates, and more time will get for melting, which is not good. Also because of the slag heavy deposition, overall metal fluidity
মিউট
reduces.
করবেন না, ভিডিওটা দেখাবেন, সাউন্ড মিউট করবেন, সাউন্ড মিউট করতে গেলে এটা ভিডিও।
Yeah,
Please mute your mic. If you have any questions, please mention to the chat. We will address it.
yeah.
Thank you.
A tendency for inclusion and slag related rejections, that will also increase. Furnace lining life will reduce. So with heavy buildup, these are the challenges. So the phenomenon elephant foot is this because of the breaching, this will happen, and this is really not good condition for furnace, and no, it will lead to furnace, like coil puncture, and very costly runouts, and also from safety point of view it is very dangerous. So we must take care of these type of slag buildups. Another challenge, like use of coated scrap. So this we can say some recent updates, like whether it is BS6 vehicles, or the norms which are getting stringent, like use of galvanized steel for car bodies, or basically car bodies and light vehicle bodies. So just to improve the durability of that steel, now new norms are coming, just use of galvanized steel. So galvanized steels are nothing but it is zinc coated scrap, and zinc coated scrap, you can see the actual photographs. When we use this type of scraps, the amount of fumes, so this environment point of view also dangerous, and it leads to gas defects. In some critical castings we have seen that gas defects have increased like 0% to 8%. So this is very huge losses to foundry, and a challenge. So we know the challenge. Means foundry, as a foundryman, we are facing these top challenges on day-to-day basis. However, foundries are devised with their own methods to overcome these challenges. But still, we feel that there is a need of a product which can help to overcome these challenges in a methodic way, consistently, repeatedly. So that's why we have come up with the solution, which is ferrogene LF10X. So ferrogene LF10X like these are some actual product photographs. 25 kg bag, it will be there, and the EU it is called as induction furnace cleansing agent. So basically, it is designed to overcome the challenges which are related to induction furnaces. We have discussed those challenges, and how like it, how it will help. So it will take care of the issues definitely, and very consistently we have seen if we use this product that we can discuss in next slides also. There is a specific SOP for that, and if you follow that, then definitely we could see the results repeatedly and consistently. Can be used for iron foundries because the product is acidic in nature, and as we know, the nature of slag in iron is acidic. Lining material, ramming mass is also acidic in nature. So uh, to work on those linings, this product is designed, which is acidic in nature. So if we are getting clean furnaces, that means the power consumption will definitely reduce because of the heavy buildups. If it is not there, then definitely we can extend the furnace lining life, and that will result in reduction in downtime. So overall, higher productivity and savings. So function, how it functions. So it fluidize the non-metallic particles and prevent adhesion of these non-metallic inclusions to furnace wall. So basically, it is ensuring like whatever non-metallic inclusions are getting generated, and when they form a slag, this material will react with this slag and will not allow these particles to stick to the furnace lining wall. Then where it will go? So it will float on the furnace surface only, and it will not means it will, this slag will get converted into easily removable slag. So whatever slag which is going to deposited on furnace lining wall will not get deposited, and it will remain on the furnace surface, which can be easily removed before we tap the metal. So this already we have discussed. So overall, if buildup is not there, then the mechanical working of, because slag removing or deposition removing is not a pleasant job. Operator will not like this, and if it gets reduced, if buildup is not there, then he this overall ease of working will improve. Increase energy efficiency leading to reduction in power consumption. So like, so these are all associated benefits. If slag buildup is not there, or if it is very minimum, then our furnace flux linkage will also be improved, or it will maintain like what it was like for new lining. So it will maintain in that range. So again, this dangerous and costly furnace runouts, that also no, it will be taken care. Huh. Any question? Maybe at the end of the presentation, we can have a separate session for discussion and question answers. So is that
Yeah,
okay?
yes, we will have 10 minutes at the end for question and answers. So please make a note of it on the chat, and then we'll address it one by one. Yeah,
Yeah,
proceed, sir.
thank you. Yeah. So some comparative photographs, like this is before use, like in one of the country before a regular operation, the very heavy deposition.
So this one, yes.
And after use of ferrogene, so you can see the clean lining walls. Then instructions for use. application rate, we are arrived at 0.05 to 0.07 percentage of liquid metal. So that is the addition rate. However, for a different foundry, it will vary. Foundry means furnace size, their charge mix quality, temperature, operating temperatures. Based on that, it will vary. Then only we will discuss SOP also. But the application rate, whatever is applicable for a given foundry, that application rate should be maintained, and that amount of addition should be done for every heat in the furnace, along with every charging. So that is one discipline. So whatever buildup is there, maybe old buildups, chronic buildups are there. Do not try to clean those buildups, because there is a risk, since this grade is acidic. If you use in excess in a localized area, then it will erode the lining, and that is not recommended. So as mentioned, along with the charging, in charging trolley, or if it is manual charging, then also along with the solid charge, we need to add this ferrogene. And uh, uh, again, when furnace lining is newly lined furnace, then let 4-5 heats go. Then we also,
I request you to please mute your mic.
so in SOP we will see the details. So along with this ferrogene, if we use Foseco slag 30, then slag removal is better. So slag 30 is something which helps to coagulate the slag, which is like when we use ferrogene, more slag will get generated. That is the very obvious observation one can have, because whatever slag is going to deposit on furnace lining wall, that will come up on the surface. So you will observe the slag generation is more after use of ferrogene. So to remove that,
Excuse me, please mute your mic. You're disturbing the technical webinar. Thank you.
yeah. So to remove that generated slag, use of slag 30 is recommended. So for better removal, slag 30, which forms the high volume and low density crust, a single layer on the slag, which is scattered all over the surface, and in one go you can easily remove a lot of slag. So in 1 or 2 cycles, you can maintain the furnace clean. So like mentioned here, along with the solid charge, you can see these pouches. Though the standard pack size is 25 kg, but it is advisable that we can make small pouches, depend on the addition rates, and use it along with the solid charge. So on SOP side, I'm just opening it. So is it visible? Standard operating procedure?
Yes, it's visible, sir.
Yeah. So as mentioned earlier, some basic disciplines we need to have to get these benefits out of the product. So one discipline is its consistent and regular usage. Like whatever addition we decide, the same addition, and for every heat we have to use. And when we have to start, like we have to use it on newly lined induction furnace. Lining must be acidic, and also we have done some trials on neutral liming. So on neutral also it is working, but that is for steel application. Maybe we can discuss in our question answer session. But it is it should be acidic lining, acidic ramming mass. And once around 4 to 5 heats are completed, taps are completed as per the regular way, then ferrogene will come into picture. So why it is not advisable to use from first heat? Because of the acidic nature of the ferrogene. So after initial 4 5 heats, one barrier of metal will get formed on the lining, and then we can use ferrogene. So for every heat, and addition rate, it could be like a wide range, 0.05 to zero point 0.1. In some foundries we can use at 0.03 also. So number, if we need maybe 0.05, then we should start with 0.03. And again, means depend how it goes. Like initially after 10 15 hits, if we see there is there is no deposition, then we can continue the same addition rate. If we see there is small deposition started, then we can increase 0.03 to 0.05. And then observe. And also, if furnace, like for example, if we arrived at addition rate of 0.07, that means for one ton of furnace, around 700 grams we have to use. But when the furnace capacity increases, like if it is 10 ton, then 7 kg it could be the addition rate. But 7 kg at a time we should not add. So when and where to add? That when furnace is filled at least 30%. For example, 1 ton furnace, then at least for 1 ton furnace, at least there should be metal around 300 kg. So after 300 kg, we can we should add the.
Please mute your mic.
So
Please make sure your mic is always muted.
when furnace is more than 3%, 30%, and less, we have to add kerosene. So for, so for bigger furnaces, it is advised that do not use in, like, or it is, if it is 10 ton furnace, then 7 kg should not be added at a time. So we should add in like uh, in three installments, we can say, like uh, uh, 3 kg, 2 kg, 1 kg. Yeah. So means one is addition rate and other is when and where. These are the two very important points to be remembered while using ferrogene. So this extra care need to be taken when furnace sizes are like bigger, like 3 ton and above. Then we have to add ferrogene in installments, like as I explained. So that additional care is important. And as mentioned earlier, use of stack 30 in conjunction with ferrogene will definitely help. So this is the SOP. Uh, okay. Then what are the economic benefits for the? So like regular usage, it results in 3 to 5% of less power consumption. So for example, if you take some in HRN foundry, it is the average energy consumption for melting could be around 650 kilowatt hour per ton, and with the use of ferrogene, it could be reduced by up to 630. So around 20 units per ton can be reduced. And in terms of money, what benefit? Like foundry, if it is producing 1,000 tons liquid metal per month, then annual saving could be in the range of 10 lakhs. So that we can see a separate Excel sheet, that EVC. economics, the benefits to a foundry. Apart from these monetary benefits, other intangible benefits we can say, like improvement in productivity, lesser downtime, overall fatigue, operators fatigue will be reduced. It will add more safety. Overall reduction in slag related rejections. Yeah, by any chance, if any slag is missed, because more the slag, there are highly chance, or when slag is deposited on wall during tapping, there is highly chance that it will get away from the wall and mix with metal, and will continue with transfer and contaminate the casting. So that type of slag related rejections will definitely come down. And overall, if with all this, overall throughput, or we can expect that our melting rates will be intact, like uh, when from starting to end, we'll get consistent output. So like earlier, before joining to Foseco, I was working with Kirloskar Foundry for close to 5 years, and I was working melting and overall production. So that time I was not aware about this type of products. Means because for any foundryman, if it is energy or furnace related thing, for example, saving. So majority cost is associated with melting, and if I could have this understanding that time, then it was very excited. Like I would have definitely gone for this. That time it was not there, but now when I joined Foseco, I am now on other side of the table, and definitely now also very excited, and like if and would definitely recommend use of this type of products, which will surely giving benefits to the foundryman. Also, we can see these new initiatives on sustainability are coming up, like our contribution towards environment. So if we could able to save some energy from this type of initiative, would definitely add value to our society. So that is another angle to this. Just to I have prepared one Excel sheet, like how these benefits we have calculated. Very simple calculation. Like around 3% energy saving could achieve because use of ferrogene. Just existing process, nothing, no furnace scavenging or ferrogene like product. Energy is around like 650 units required per ton. And if you could like six rupees is the unit cost of per unit, then total cost. And when use of ferrogene, these are just example. Addition rates and all other points may vary, but definitely around 3% to 5% saving. These yearly for 1,000 ton producing foundry, it is close to 10 lakhs saving. So it is really huge. And what about overall trial validation period and all? So application is simple. Like just we have to add the pre-decided quantity. Where to add, that also we have discussed as per the SOP we have to add. So application wise, no very not very challenging, but uh, we have to follow the SOP strictly. Like if operator forgets to add, then he cannot add on top, because if you add on top of the furnace, then induction furnace, that stirring effect is between that middle of the furnace where active coil is there. So if you add when furnace is like close to full 80% and above, so addition of ferrogene at that level will not help, because that churning effect will not be there, and definitely certainly it will not solve the purpose. So that's why it is important to follow the SOP, where how much and whatever quantity we decide, we have to add that quantity only. So uh, one easier way could be no, per shift we can, if per shift 8 heats are coming, 8 furnace are coming, then 8 pouch prevent of this material. Like if 700 gram per furnace is required in a shift, 8 furnaces are coming, then we can like that we can maintain this prepayments, and thus we one could ensure that all means it is for all heats material is used. So like that, uh, some way it is simple in terms of application. Then minimum campaign, one furnace campaign is required, because furnace start to end, like maybe for iron foundry 300 heats is average life, then for entire 300 heats, if it is 1 ton furnace, then 300 tons for that period we have to wait, like in terms of the cleanliness, lining life, other parameters also. For example, energy. So energy meter, if it is dedicated for furnace, then also in one campaign we can easily conclude like how much energy consumption has reduced, how much energy is saved. So these are some guidelines on validation. So minimum one furnace campaign, follow the SOP strictly, and if it is dedicated energy meter for furnace, then conclusion would be easy for on energy consumption. So there are total three different grades of ferrogene. The the working is similar, like it is not allowing slag to deposit on lining walls. So ferrogene LF10X, which we have discussed for induction furnace, the same ferrogene LF10X can be used in ladles also, but the metal should be gray iron. And for AG iron metal, we can use ferrogene 146, different grades in ladders. Addition rates, again, these are guidelines, can vary. Another grade, ferrogene 12, that is also for gray iron, and basically for when it is cupola metal. So these are some additional information on grades. So I think we have covered this part of this presentation, and now we are open for discussion, questions. Thank you.
Now the floor is open for questions. Feel free to ask any questions and we can address it. So one of them has asked for the ferrogene data sheet, sir,
Okay.
to be shared. I think that will be helpful for them. Any other requests or questions? All right. Then that's
The
if
topic,
everybody.
they understood it very clearly. Maybe no
Maybe
questions.
it was very clear, I guess. So let's make it a wrap then. I thank Mr. Vivek for for his lovely time and providing valuable information to all our members in IF. We are sorry, sir. We had some disturbances during your speech, so we will try to rectify it the next time. But then, thank you for sharing your valuable knowledge, and I'm pretty sure many of us have been, taking this session very seriously and benefited from it greatly. So we would love to have your involvement more in IF and looking forward for more events from you. Thank you, sir.
Yeah, same here. Thank you, and very nicely organized. And as I in the beginning of the meeting, as I told, this is very good platform to connect with Foundrymen and experienced people. So really
Correct.
appreciate and very grateful for inviting me.
Thank you, sir. Thank you. And for all others, the session has already been recorded. So it can be the link will be shared or it will be posted in the YouTube channel for your reference as well. So, yep. Thank you, everyone. Thanks for attending, and let's wrap it up today. Thank you, sir. Thank you.
Thank you. Thank you.
Yeah.